Okay, hello everyone. So in this lecture, I want to discuss two questions of shear center and shear flow based on property, a kind of you can say concept and theory. It is not numerical because in your gate exam they cannot ask that much difficult and lengthy gate numerical for gate exam. So they, as of now, if you see up till now, they have only asked the based on your properties of shear flow and shear center. So they cannot ask for the lengthy numerical because that becomes very lengthy, which is not for gate. Okay, this will not forget. Okay, so in this question I have picked from T.H. Maxon book, uh, father of your aircraft structure. Okay, so let's see what they are saying and what they are asking. So this kind of question you can expect for your gate exam, gate 2023. Okay, so let's read the question. Idealize the box section shown in figure into a arrangement of direct stress carrying booms positioned at the four corner and panel which are assumed to carry only shear stresses. Okay, so I hope you got the idea what this sentence is saying. So they are saying assume it as a idealized section. Okay, hence determine the distance of shear center from the left hand web. Okay, so they are asking what is your shear center, okay, from the left hand web. So this is nothing but your web. Okay, and this is left hand side. Okay, if you try to see, this is a rectangular closed thin wall section and coordinate will be somewhere here. Okay, coordinate will be somewhere here and centroid will be also somewhere here of the structure. Somewhere it is not exactly at the center because thickness is not same, that means material present is not same. Okay, now they are saying find out the shear center. Okay, so if you see from this coordinate, shear center will be symmetry because thickness is here. If you see, thickness is symmetry, thickness is 10 mm and here it also 10 mm, so it will be symmetric. Okay, now if you see this thickness, yes, if you see this thickness, okay, if you see this thickness and this thickness, it is not the same. So can you tell me one property, it is right or no wrong? If I hope you have read in T.H. Maxon book, uh, where the material is more, shear flow will be more at that side, and where the shear flow is more, there the shear center will lie. At that side shear center will go. Okay, so if you see carefully, this is 10 mm, this is 8 mm, so obviously at this side, at this web, shear flow will be more. Okay, so shear flow will go towards somewhere here, it will go towards somewhere here, that means it will be somewhere here. So can you tell me, because here thickness is more, right? So shear flow will more, so shear center will go somewhere slightly towards the left hand side. Okay, so can you tell me from this and using option, what will be which option is correct? So according to this is exactly at the center, it is 250 mm at the center, right? You see from here it is 250 centimeter to 250 mm, and it cannot be, this option cannot be, this option will be wrong. 275, that means saying you are going at this area. 255, again this is going, they are saying going in this area, but the right answer is 225, it is somewhere left hand side because 255 is some closest distance. Okay, so option A is correct in that case. Okay, okay, I hope you understand this question. This was theory question, brilliant question, they can ask for 2 marks, although people will feel that this is a numerical question, but it is not, it was theory based question. Okay, let's see that question. Okay, let's read. The thin wall structure This is MSQ, be careful. This is a thin wall structure is shown in the figure with a shear force applied at point 8. This is point 8 and shear flow is applied at this point. Mark all the wrong option. Let me mark all first wrong option, then I will explain why this is wrong. Okay, so if you see carefully, this is the again I have picked from TH Maxon this question, and they can frame in such a way that this should look like a MSQ and not a numerical. Okay, so let's read. They are saying mark all the wrong option, be careful. Okay, so let's read. So this kind of section they have given at point 8, they are applying shear force. So if you see carefully, this is doubly symmetric cross section. So shear center will be somewhere here, and CG of this structure will be somewhere here at the exactly at the middle point, exactly at the middle of the structure. Okay, so option A, if you read, they are saying bending will happen as well as twisting of cross section will happen. So according to the question, this is wrong. Option A is wrong. Shear center will be exactly at the center of cross section and coinciding with CG. This is again wrong according to the question, because we need to pick wrong option, right? Only twisting of cross section will happen. So this is the correct option as from as question is saying, pick wrong option. And only cross section is doubly symmetric cross section, so IXY will be 0. So this is also correct. Can you tell me why these both options are wrong? Because in this case IXY will be 0. In doubly symmetric cross section for thin wall, IXY becomes automatically 0, relative moment of inertia. Okay, and option C, if you see, only twisting of cross section will happen, they are saying, but it is not, because when shear force is applied at somewhere here from shear center, twisting of cross section will happen and bending of the beam will also happen. So both the thing will happen. When shear force is applied at the shear center, exactly at the shear center, so only bending of cross section will bending of beam will happen. Okay, there will not be any twisting. So I hope option C is clear, why only twisting of cross section will not happen. Okay, option B, if you see, shear center will be exactly at the center of cross section and coinciding with CG. This is absolutely fine, this option is okay. Bending will happen as well as twisting of cross section happen, I have explained this already. So if they say pick mark all the correct option, then A and B is fine, but they have said pick mark all the wrong options, so C and D is in that case is right. I hope this is clear to you. If not, you can ask me in comment section. Okay, so this kind of question you can expect for you from your GATE aerospace exam, or maybe mechanical they have also framed this kind of question. Shear center is also present, I think, in Torsion for the thin wall structure. So I'm telling you guys, because the theory based thin walled structure question is already asked for 2 marks, and generally if you see from 2017 they are asking this kind of question. I hope you have seen this structure, this question they have asked us like this. They have marked the point A, B, C, D like this, and they have asked where the shear center will be present for this structure. So can you tell me where the shear center will be present for this structure? At this point, at this point, at this point, or at this point? Definitely the shear center will be this, because this is the junction of these two we can say part. Okay, so this is not a simple thing. They can ask this kind of question only, they cannot ask the numerical from these concepts. Okay, so I hope it is clear, and I hope this help you a lot. Okay, so let's meet in the next lecture. Thank you.